All right, I'm going to go over Reteaching 14-4. Before I start, I'm going to make my screen to 100% to be easier to read. It says, now you have learned how to draw plot lines, which we did last week. Now you can analyze, which just means think about it, answer questions, the data in the line plot. Mrs. Calderwood separated the rock samples in her science classroom using their densities. She made a line plot of the data. So density is kind of just how thick it is. You don't have to worry about knowing what that is in order to complete this assignment. The title of the graph or the line plot would be density of the rock samples. And down here are our measurements. Now, I am looking here, and before we begin, I want to make sure we understand that this is a plot, and it goes 1, 1 1/4, 1 1/2, 1 3/4, 2. Then it repeats, 2 1/4, 2 1/2, 2 3/4. So the things you are not seeing right there are the 1/4 and the 1/2. So I'm just going to make a little note, 1/4, or not one, I'm sorry, it's and 3/4 are the ones that you are not seeing on there. So, and actually I'll just go ahead and put the half in there so you know the order. Okay, it says find how many rocks were used in the line plot. So when we're counting how many rocks or whatever is in the entire plot, all we have to do is count the X's. So I see 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 X's. So then how many rocks is that? There are 20. Number of rocks used in the line plot are 20 rocks. Okay. Which density occurs most often? Well, whenever you see the word most, it's going to be the line that has the most X's. So if we look here, it's this one. And if you remember, right after the whole number comes the 1/4. So 1/4, and the whole number is the 2. The density that occurs most often is 2, and put a space, 1/4, then I hit the space again, and it will make it into the fraction. Let me go change my answers to red just so they do stick out a bit better. All right, what is the difference? Different keyword for subtract. I need to make my little letters here. Come here. Subtract. Oh, I spelled it wrong. There we go. What is the difference between the greatest density and the least? So I'm going here and I'm looking at my greatest, which is this one right here. I will make it the color. Oh wait, is that going? Border color, I'm going to make that green. And the least dense is this one right here. I will make that, and you do not have to do this. I'm just doing it so you can see it better. And I will make that color blue. Okay, so in order to subtract, I need to figure out what this is. This is 3 1/4 minus 1 3/4. So let me write that problem over to the side here. The problem is 3 1/4 space minus 1 3/4. I will tell you this is a not where you already have the same common denominators, but you do need to borrow from the whole number up in the 3. And I will do an example of that here in a few minutes. I should put a border around that. And then Monique says that 3 1/4, then that's the label for our, right here, our data, is an outlier. Is she right or wrong? Well, if you remember, an outlier is like an outsider. In order for us to have an outlier, it would have to come like way over here or way over here. So since all of these X's are grouped together, there is no outlier. There is not an outlier because all of the data is grouped together. You can explain it a lot of different ways. That's just one. So here in a minute, I will get my document camera out and I will do this problem for you.